Hello everyone, Mr. Tomashik here. Today we are going to do the lab called Types of Chemical Reactions. In this lab we're going to perform 8 different chemical reactions. At this point you should know how to balance chemical equations and also know the 5 types of chemical reactions. The reactions we're going to do are going to either be synthesis or decomposition, single replacement or double replacement, or combustion reactions. So these 8 will fit into one of those 5 categories. All right, let's take a look at the reactions that we're going to do in the lab. First, let's get some goggles on. Reaction number 1 is a reaction of methane gas with oxygen. For that, we're going to use a Bunsen burner. Reaction number 2 is a reaction between zinc metal and copper 2 chloride. Now, zinc metal will look like this, and copper 2 chloride is in a solution. Reaction number 3 is a reaction between copper 2 chloride solution and sodium phosphate, which is also going to be in a solution. Number 4 is the decomposition of H2O2, which is hydrogen peroxide. And reaction number 5 is the action of heat on copper sulfate pentahydrate, which looks like this. And then reaction number 6 is between magnesium metal and oxygen. Reaction 6 is solid magnesium, which looks like this, with oxygen gas. And number 7 is a reaction between magnesium metal and hydrochloric acid. And there's going to be one more reaction that's going to be related to number 7. All right, let's take a look at reaction number 1. Wait, before we do that, we got to do a couple of demonstrations. The first demonstration is the production of H2O water vapors via a chemical reaction. How do we know we've created H2O? Now, all combustion reactions, including this one with a little lighter, produce 2 things, carbon dioxide and water vapor. Now, both of those are invisible, so you really don't see anything except for the flame. All right, if we want to detect the production of water vapor, we could do this. We could take a somewhat cool beaker and we could put the flame inside. And what we notice is that condensation starts to occur on the inside of the beaker. That condensation, that fog that you see, is water vapor condensing on the inside of the beaker. So that's a way that we can test that a chemical reaction is giving off water vapor. Number 2, production of H2 hydrogen gas via chemical reaction. How do we know we've created H2? And number 3, the production of oxygen, O2. Now, here I have a couple of reactions that I already did. On the one on the left contains hydrogen gas, and the one on the right contains oxygen gas. Now, how does one test for these? To test for hydrogen gas, we do this. We take a wood splint, which we light on fire, and then we're going to hold it over the mouth of the test tube that we think has hydrogen gas in it. And then we get a small little explosion because hydrogen gas is flammable. To test for oxygen, we blow out the splint and keep it glowing, and when we put that down in there, it relights. So the test for oxygen is that it can relight a glowing splint. So those are our 2 tests to test for hydrogen and oxygen. So we can write that down. Number 1, the production of H2O, condensation is going to happen inside a beaker. To test for O2, H2 gas ignites, and for oxygen, it can reignite a glowing splint. So some of our reactions are going to do this, and that's how we're going to test what the products are for our chemical reactions. All right, let's look at our chemical reactions. Before we start, let's read our safety instructions. Number 1, safety goggles must be worn over your eyes at all times throughout the lab. Number 2, hydrochloric acid is corrosive and can cause serious injury. If you spill it on yourself, flush the area immediately with water. Copper 2 chloride is an irritant. Avoid contact with your skin. Okay, reaction number 1. The reaction of methane gas, which is CH4, with oxygen. Now, in our data table, we can write this down as the reactants. That would be CH4 plus O2, a diatomic molecule. Now, for this, we'll have to go to the kitchen because we don't have methane down here in the basement. Okay, now I'm in the kitchen where we have a stove that runs on natural gas. On this particular stove, we can remove the burner, giving us access to the gas. In which case, we can take a Bunsen burner and connect it to our natural gas line. And then there we go, natural gas. Now what we want to observe here is the beaker. We're going to take the beaker with a beaker tongs and we're going to hold it over the flame and notice the condensation that occurs inside the beaker. That is demonstrating that water vapor is being produced in the chemical reaction. All right, let's jot down some data. All right, here's our 2 reactants. Methane, which is part of natural gas, plus oxygen, which just comes from the room. All right, when we put the beaker over the flame, we noticed some condensation. All right, that's proving to us that the reaction is actually producing some water vapor. All right, we can write that in here too as well, H2O. Now it also produces carbon dioxide, but that's always invisible and we can't see that. All right, so that just escapes and becomes part of the air in the room as well. All right, so that's our first reaction, the reaction of methane with oxygen to produce carbon dioxide gas and water vapor, which we condensed on the inside of the beaker. Reaction number 2, reaction of zinc metal and copper 2 chloride. It says place 5 to 15 drops of 0.5 m copper 2 chloride solution into a small test tube. Add a small piece of mossy zinc. Record your observations. The reactants are zinc and CuCl2, Zn plus CuCl2. All right, first we'll put some of the copper chloride solution into the test tube. And then we're going to add a little bit of the zinc. All right, zinc looks like this, so we're just going to take a few chunks of our mossy zinc and see what it looks like. They're kind of shiny, all right, a shiny metal, and we'll put a little bit of that into our test tube and then observe what happens. All right, take a look at it. The zinc right away starts to turn black. It starts to turn black, changes color, it's reacting. All right, notice when we shake it up, then it gets little black flecks of solid material, kind of brown too, it looks like, that are falling off of the zinc. All right, so that's our observation. A black substance is formed, a black ore. Actually, it looks kind of brownish color as well. All right. All right, after we let it sit for a while, let's take a look again and see. We now have a solution that has lost its blue color and it's sort of a goldish looking substance that is forming inside of the test tube. Now, what do we suppose that sort of brownish stuff is? The solution lost its blue color and the solid turned brown. All right, we're going to say that that solid is copper. Copper, so copper is formed in that chemical reaction. Reaction number 3, copper chloride and sodium phosphate. Place 6 drops of copper solution into a test tube and then add a few drops of sodium phosphate. Swirl the test tube, record your observations. Okay, a little bit of copper chloride into the test tube. Then we'll add a few drops of the sodium phosphate, which is just a clear solution. And then we'll see what happens. All right, shaking it around, and we notice that sort of turns cloudy, and some white globs of stuff are forming inside of the test tube. If we shake it up, we can see some of that white stuff sticking to the outside of the inside of the test tube. Sort of getting a milky whitish color. Let's let it sit for a little bit. The reactants are CuCl2 and Na3PO4, sodium phosphate. The products should be a solid copper phosphate and an aqueous sodium chloride. Now the test tube has been sitting for a little while. Let's take a look. I added a little more sodium phosphate to it, and it looks like we got some sort of a solid that is sort of sunk to the bottom of the test tube, and the liquid has sort of turned clear. So that solid material is our copper phosphate. For data, let's say that the solution got clear and a solid precipitate forms. A precipitate is a solid that forms during a chemical reaction. In this case, the copper phosphate solid is the precipitate. On to reaction number 4, decomposition of H2O2, which is called hydrogen peroxide. Place about 1 milliliter of hydrogen peroxide into a test tube, add a small amount of catalyst, and watch the reaction. Hydrogen peroxide, which is H2O2, this stuff you can find at home in your medicine cabinet. A lot of people use it as an antiseptic for cuts and scratches, things like that. We'll put a little bit into a test tube, and then we're going to add a catalyst. That's a chemical that helps a chemical reaction happen. In this case, we're going to use manganese dioxide. A small amount of that is going to go into the test tube, and it starts to bubble and fizz. All right, we'll shake it up a little bit here, and then I'm gonna cork off the top because it's producing a gas. Little tiny bubbles are forming there. All right, now question is, what is that gas? See if we can see it up close here. All right, there's some bubbles forming. It's decomposing. That's what's happening here. It's decomposing. All right, let's let that sit for a minute. For data, we're going to write this, H2O2. Now, we're calling the MnO2 manganese dioxide a catalyst, so we are going to write that underneath the arrow because it's not going to really get used up during the chemical reaction. That's what catalysts do. All right, now for data then, we'll just say bubbles of gas are formed here, and let's take a look. It says while the reaction is still occurring, we're going to hold a glowing splint over the mouth of the test tube. All right, let's light a splint here, a wood splint, and we're going to blow it out. And while it's still glowing, we're going to put it in there, and it reignites. It reignites. What does that mean? That means that the gas that is produced must be carbon dioxide, or excuse me, oxygen. Remember the experiment we did at the beginning. So a glowing splint reignites in the gas. So for data then, we're going to say that bubbles of gas formed and a glowing splint reignites. That means that one of the products must be oxygen gas. We'll write that in, O2, oxygen gas. Reaction number 5. The action of heat on copper sulfate pentahydrate. Now, what is copper sulfate pentahydrate? The formula for copper sulfate is CuSO4. The pentahydrate means that each one of those molecules has 5 water molecules attached to it. It's called a hydrate. There are lots of compounds that do this. They like to have water stick to them. All right, and copper sulfate is one such a compound. It says place 2 or 3 pea-sized crystals of it into a test tube and hold the test tube at an angle using a holder and gently heat it. So I'm going to put a few of these crystals into a test tube. There we are. Let's put a few more in there. And then it says to gently heat it. All right, we'll hold the test tube with this. Then we need a Bunsen burner. So here's our Bunsen burner flame, and we're going to hold that in there and gently heat it and see what happens. All right, let's give it a minute or two here. All right, it's been heating for a while, and notice that the blue crystals are starting to get white. They're starting to get white. So it's changing color. The blue crystals are changing color. Another thing we want to notice is this. There's some condensation happening at the top of the test tube. Condensation is happening at the top of the test tube, and the crystals are turning white. Now remember at the beginning the little demonstration we did? What does it prove when you see condensation on the inside of the test tube? We're going to say that water vapor is being given off during this chemical reaction. And the crystals are turning white. All right, let's record some data. The reactant was the CuSO4.5H2O, copper sulfate pentahydrate, and the crystals turned white, and condensation occurred on the test tube. So we're going to say this, that one of the products of that is water vapor or water gas. So the white crystals then are the copper sulfate without the water attached, and the water comes up the test tube and condenses on the sides of the test tube. Okay, reaction number 6. Reaction of solid magnesium metal with O2 gas in the presence of heat. Obtain a small piece of magnesium and use crucible tongs. Hold it into the cone of a Bunsen burner flame until the reaction begins. Record your observations. All right, obtain a piece of magnesium metal that looks like this, about 2 centimeters. All right, there we are. And then we're going to put that into a Bunsen burner flame. Here's our Bunsen burner flame once again. And we need a tongs for this. Okay, here we are. We have our piece of magnesium, and we're going to hold it into the flame here until the reaction starts. The flame's getting yellow, sort of orangish color. And the reaction starts very bright. It says don't look at directly at the magnesium. Now, here's what happened. It burned, and then the magnesium sort of turned white. White color. All right, let's take a look at that. Let's take a close look at our magnesium metal. It looks like it formed into some kind of a white powder. Some of the magnesium is left unburned, and it turned into sort of a white powder. What is that white powder? Okay, record some data. What we have is magnesium metal plus oxygen is going to turn into MgO. Right? The MgO is that white powder. That's called magnesium oxide. So when you burn magnesium in oxygen, you produce magnesium oxide, which is the white powder. Okay, a couple more. Reactions number 7 and 8. Reaction of solid magnesium with hydrochloric acid. Add about a 1 milliliter of hydrochloric acid to a test tube, 2 centimeter strip of magnesium, and add the piece to the acid and stopper the test tube. This is reaction 7. All right, let's see what that's going to look like. First, a little bit of hydrochloric acid. To the test tube. And then a small chunk of magnesium metal once again. All right, we're going to take this, sort of bend it up so that it can fit inside there. And then we're going to drop it in, and right away we see lots of bubbles and fizz happening there. All right, so bubbles are forming inside there. And the magnesium sort of disappeared. Now, you can't really tell by looking at this, but if you feel it, it is actually quite hot. The solution gets very hot. That means it's exothermic, which we'll learn a little bit more about later down the road. All right, so that's reaction number 7. Reaction number 7. Let's record something. Now the reactants are magnesium and hydrochloric acid, HCl. And it produces some kind of gas. So I'm going to tell you that that gas is hydrogen gas, H2. All right, in reaction number 8, we're going to prove that that is so. All right, and it's also gives off a lot of heat. We'll write that down too as well. It gives off a lot of heat. All right, for the last reaction then, number 8, we're going to do a test of the gas in the test tube. Let's see what that's going to look like. For reaction number 8, then, what we're going to do is hold a lit wood splint, a burning wood splint, over the mouth of the test tube. Now, we've got a cork on the test tube, and what we're trying to prove here is if it is hydrogen gas. So I'm going to put the lit splint over the test tube, and we get sort of a pop sound. It ignited. That is indicative of hydrogen gas. Hydrogen gas. That is our reaction number 8. Let's record some data. Now, that pop sound that you hear there is the hydrogen gas that was produced in reaction number 7 plus oxygen, so it kind of burns. And what is produced? Water vapor, which we really can't tell, and energy, that's the ignition there. So we're going to write down ignition for an observation. It ignites, proving that it is hydrogen gas. Hydrogen gas. Okay, here is our completed data table. You can pause the video if you miss something to jot that down. The next thing we need to do is complete the chart at the bottom. All right, so let's do that. This is the chart that has one column for balanced equation and another column to identify the type. All right, now I'm going to leave the balancing to you and the identification of the type to you, but let me help you fill this in with the equation. All right, now reaction number 1, that was the methane plus oxygen yielding carbon dioxide and water. So that will look like this. Now, when you write this down, leave a little bit of space in front of your formulas so that you can insert some coefficients to make it balanced. All right, I'm going to leave that part to you. All right, the second equation then is zinc plus copper 2 chloride yielding zinc chloride and copper solid. All right, that will look like this. Now remember to leave spaces for your coefficients. Now it's not required here, but you could write in state symbols too. In this case, the zinc was a solid. The copper chloride started out as aqueous. And the zinc chloride then ends up as aqueous. And the copper ended up being a solid. All right. Reaction number 3. Copper chloride and sodium phosphate yields copper phosphate and sodium chloride. That reaction will look like this. Now, remember to leave space for the coefficients, and this one we may also want to write in the fact that the products here, one of them is a solid, that's the precipitate one, is aqueous, stays dissolved in the solution. All right, when we started, both of them were aqueous, and when we ended, one of them was a solid, the copper phosphate. All right, reaction number 4. H2O2 with manganese dioxide as a catalyst, hydrogen peroxide. All right, that reaction will look like this. H2O2. Now, the fact that we have manganese dioxide as a catalyst, we're going to write that in underneath the arrow as MnO2. That's how we show a catalyst. And then we could also include the fact that the oxygen is a gas. And then we did the test for oxygen, reigniting a splint to prove that that was in fact oxygen. All right, now notice then that leaves us really with just one reactant. That'll give you a clue as to what type of reaction this is. All right, reaction number 5, which was the copper sulfate pentahydrate with heat. Reaction number 5, that will look like this. Now, let me give you a clue here. The copper sulfate pentahydrate is actually one thing, all right? So there's no plus sign on this side of the equation. So that's really just one thing, and then in the end, we end up with 2 things as well. This one should be pretty easy to balance then because of that. So a clue to as which type of reaction is this. Okay, reaction number 6. Magnesium plus oxygen produces magnesium oxide. The MgO product was that white powder that was on top of the beaker. Reaction number 7, magnesium with hydrochloric acid. That was the one that produced the hydrogen gas. So maybe we can include that in the equation, that the hydrogen is a gas. The magnesium chloride stayed as an aqueous solution in the test tube. Reaction number 8 then was H2 plus O2. We tried to prove that the hydrogen gas in number 7 was in fact hydrogen. In this reaction, H2 plus oxygen. The oxygen now comes from the room. The hydrogen was in the test tube, and there's going to be one product in this chemical reaction, and that product is going to be the water that was produced. Now, we did not try to prove that that was water in there, but there's only going to be one product in this reaction that's gas, probably gaseous water vapor as well. All right, the rest of this then is for you to add coefficients in here to balance each of these and identify the type of reaction that it is. All right?